Hello everybody, we are back again. Welcome to my channel. Please do not forget to like, subscribe and share. So now today we'll be doing our lesson again on organic chemistry. So now today we'll be focusing on haloalkanes. Okay, so these compounds are alkanes in which one or more of the hydrogen atoms they have been replaced by a halogen atom. So now check something. When we did our alkane, we knew that when it is like this is a methane, right? So methane has 4 hydrogen atoms. But now in this case, one of these hydrogen atoms has been replaced by a what? A halogen atom. And that halogen atom, it is represented by the thing, or by the alphabet X. So X, it is the what? The halogen there. So now you'll find that you have something like this. C, H, then here you will have X. So whenever you see that you have X, know that it is the what? A halogen. But before we continue, let's go. What is the general formula for haloalkanes? The general formula for alkanes, it is what? CnH2n plus 1x. Can you see it? So this is the general formula, and then it is saying plus 1x. This x, it is the what? It is the halogen atom. Mara, now what are those halogen atoms? The possible halogen atoms that we may find in organic chemistry. We may have fluorine, chlorine, and what? Bromine and iodine. This Cl, usually they write it like this, or they have like in that way. So yeah, please try to do it in that way. So now these are the what? Are the halogen atoms that I'm talking about. So now in this case, it is CnH2n plus 1x. Can you see it? So now we are gonna continue. They're saying that haloalkanes are generally what you call volatile liquids. Yeah, I think volatile liquids. Yes, they are volatile liquids that do not dissolve in water. Yes, that is the truth. So now let's go to some of the simplest haloalkanes that we have. Okay, so now in this case, I want you to check something here. We are gonna start with our thing. So now the functional group, ne, it is still amine hydrocarbons, but the one that for a structural formula, it is this one, C, and then you'll have your X there. That is the one. Okay, so now we are gonna continue. Now let's start. I'm gonna use my what you call halogen atoms as my example. So on the first one, I will have something like this. Oh, this is fluorine, chlorine. So before I start, let me start with what you call alkyl groups. So alkyl groups, ne, they have their formula, they are what you call general formula, which is CnH2n plus 1. Okay, so we have meth. You know meth, it is for 1 carbon, right? So this one is what? Methyl. Okay, hey, yeah, this is the correct spelling. So that is what? Methyl group. So methyl group, you know that it is what? 1 carbon atom, then H2 times 1 plus 1, meaning that this one, it is what? CH3, and it can be written as what? Like this. We have H. Can you see it? So now, oh sorry, we have 1 carbon atom and 3 hydrogen atoms. The second one now, it is what you call eth. So it is what? Ethyl. It is what? C2H5. Can you see it? So these are our alkyl groups that we have. Because now when I'm gonna do my chlorine and whatever, I want you to understand each and everything. So now let's continue. We have alkyl groups: methyl, CH3, ethyl, C2H5. Let's go. Now let's start. We will have something called chloromethane. Chloromethane, it is what? Check something. Chloro tells you that it is chlorine, right? But methane, we did methane on alkanes. So methane, it is what? CH what? CH what? CH3, right? So CH3, that is methane. Can you see it? But now it is what? Chloromethane. So let's check CnH2n plus 1, just to be sure. CH2 1 plus 1. So it is 2 times 1, 2 plus 1, 3. So this is methane. But they said chloromethane. meaning that you'll have your 1 carbon atom and 1, 2, 3 hydrogen atoms. But they said what? Chloromethane, meaning that here, that is where you'll have your what? Your halogen, which is what? Cl. I don't know how they write it, but this is the Cl that I have. Can you see it? So now in this case, check something. You have CH3, which is bonded to chlorine. And then now we can even refer it as the what? Methyl chloride. Because remember what I just told you right now. CH3, it is methyl. Then bonded to chlorine, it is what? Chloride. Can you see it? So this one, it is CH3Cl. That is the structural, that is the what you call molecular formula. Is it fine? So on the second one, bromomethane, it is the same thing. Where they Cl, you put Br, then it is bromomethane. You see, there's nothing difficult there. So now, let me make another example. Now, let's say we have what? Chloroethane. Chloroethane now, you're going to have 2 carbon atoms. You see, 2 carbon atoms, 5 hydrogen atoms, then you'll have your what? Your what you call Cl. Can you see it? Now, if they want the what you call a condensed structural formula, CH3, CH2, Cl. That is it. Can you see it now, guys? That is what they're talking about. Now, let's continue with our lesson. So now, guys, when you're gonna continue, I wanna tell you something about what? The position of a what? Of your halogen. Okay, because you're gonna have something like this. Let me simply choose what you call an example. Let's say we have 2,3 difluoro. Is it fluoro? Yes, fluorobutane. So now di, it is what? 2. Okay, and then tri, it is what? 3. Tetra, what? 4. So now these words that I just told you right now, they are basically telling you how many halogens you have on that particular structural formula or structural what you call molecular formula. So now, for example, what do I mean by that? As you can see, this di, tri, tetra. So now on my example, I have difluoro. This difluoro basically tells me that on the structural formula that I'm gonna draw, I have 2 fluoro. I have what you call 2 halogens, or 2, this fluorine, it is now 2 times. So let's start. Now I'm gonna have to draw my structural formula. How do you start drawing? What do you do in order to have a structural formula? Start by checking this name. What is it saying? Butane. From my knowledge, I know that but already is what? 4 carbon atoms. Okay, now since I'm done saying butane, tell me that it is the what? Suffix for alkane, meaning that I'll have to put my what? My bond lines like this. I'm done. But now let's go. It is saying 2,3 di. So this 2,3, it is about what? The position of the halogen, meaning that this fluorine, it is in position 2. So now I'm gonna have what you call this fluorine here. Let me put it here, F, on position 2, and then let me put another one here, position 3. This is what I'm basically talking about. Then here I'll have my H. So this is my thing, 2,3 difluorobutane. So now this is what I was talking about what? The position. I have an example saying 2,3 difluorobutane. These are the words. Di means that it is appearing 2 times, tri 3 times, and then 4 times. So now there's something that I want to show you now. So now in this case, this, we start here. Whenever you wanna do your structural formula, you start here. You check butane. But let's start here. I have but. This but tells me that I have how many? I must have how many carbon atoms? 4. Then I draw my 4 carbon atoms. Ane, it is the suffix for alkane, meaning that there is no double bond. There is a what? Single bond lines. That's why I've put everything. Coming to these numbers now, it is 2,3. So now this 2,3 tells me that fluorine, it is in position 2 and position 3. That is why it is 2,3. And this di means that there are 2 fluorines on this structural formula. Is it fine, guys? That is what I wanted to tell you. If it is 3,3 or whatever, know that it is on the same position. Maybe you'll have F here and F up there. Do you understand me? That's how we do what you call the position of the halogen on a molecular, on a structural formula whenever you are drawing it. Okay, because that is the most important thing when you are doing these things. There's nothing much on haloalkanes, but that is the most important thing I wanted to highlight there, guys. Okay, thank you very much. I hope you enjoyed the video.